Hello everyone, good morning. Dear authors and invited guests, welcome to Technical Session 11C. I am Vidhi Ramdale and I will be your moderator for this session. On behalf of Global Education Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, that is ICICT 2026, London, UK. The 11th edition of the conference is organized in a hybrid mode. The physical event was held previously in London, UK, and the virtual event is being held through Zoom from 25th to 27th February 2026. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all participants that you all stay connected with us till the end and join us for a quick snapshot at the end. If you have any query or update, then you can write to me in the chat box. Just before we start the session, I would like to introduce you all to the chair of this session. We have with us as our first chair Dr. Michelle Coren. Dr. Michelle Coren is the head of the School of Industrial Engineering and Management at Schenker Engineering Design Art in Israel. She is an industrial engineer and researcher specializing in machine learning, supply chain, and fashion forecasting. She leads the department in training engineers to integrate technology, business, and design. Welcome to the session, ma'am. Do you want to welcome the participants?
Good morning. Thank you for being here and good luck.
As the second member, we have Dr. Ruchi Sharma. Dr. Ruchi Sharma is a minute, please.
Yeah, hello everyone.
Yes, good morning, ma'am.
Good morning, ma'am. So all the best, all the participants. So we are here to listen your research. Thank you so much for inviting me here as a session chair in this renowned conference. Thank you so much.
Thank you, ma'am, for the welcoming remarks. I would like to give a quick introduction to Dr. Ruchi Sharma. Dr. Ruchi Sharma is currently a professor in Department of Artificial Intelligence and Data Science at JECRC College, Jaipur, India. She is a member of the Asia Society of Researchers, that is ASR, IETE. She is proficient in MATLAB, Virtual Lab, Model Sim, Xilinx, CAD tool. She has presented and published papers in various national and international conferences. Now, I would like to invite the presenters to present their presentation. We now invite Pal Amutha K to present her paper titled AI-Driven Framework for Anomaly and Bias Detection in Digital Twin Systems.
Yeah, good morning all. My name is Paul Amuda, currently serving as a scientist in Center for Development of Advanced Computing, Chennai, in India. So I'd like to share my screen. I hope my screen is visible.
Yes, ma'am, we can see your screen.
Okay, fine. Yes, I would like to present my paper titled AI-driven framework for anomaly and bias detection in digital twin systems. And slide moving.
Yes,
Able to
ma'am.
see
It
my?
is.
Yes. Okay. Yeah. Thank you. Yeah. This is all overall agenda for my presentations. So as more organization depends on automated decision making, we must ensure that these systems are not only accurate, but also trustworthy and fair. This is very important things. When AI system influence operations, safety and strategic planning also, reliability and transparency are essential. So for that, our framework is built on three main pillars. That is, first one is joint treatment. It is nothing but joint anomaly and bias detections joined together we are doing. And another one is real-time adaptive learning. Third one is embedded ethical AI. Together, these create a robust and future-ready digital twin systems. So why anomaly and bias detection in digital twins? So digital twins rely on continuous streams of real-time and historical data. They use this data to predict outcomes, optimize performance, and support automated decisions. When the data and models work correctly, everything runs smoothly. But however, problem arise when some of the data quality decreases, sensor shift or fail, models develop bias over time. So for this reason and all, we are not getting the systems run smoothly. These issues do not stay isolated. They affect the entire systems. It may be lead to incorrect automated decisions, reduced efficiency, safety risk, loss of stakeholders trust also. So we call this is the operational safety gap. So another one is interconnected failures. So also anomaly detection and bias detection are usually treated separately. In reality, they are connected. A change in data can create bias. A bias model can produce an abnormal result, nothing but anomaly also. If we monitor them separately, we may miss important risks. So that's why that is anomaly and bias detection together, we are joined together, make us a framework. So necessity of the proposed systems. So let's briefly look at common limitations like fragmented detections. If the detection systems are separated, it may be creating blind spots. Data issues like missing values and sensor errors reduce reliability also. Many systems do not use feedback to correct themselves. Bias increases over time when models are retrained on biased data or black box models reduce transparency and trust also. Real-time scalability is another one of the limitations in difficult in industrial environments. So these challenges shows the need for our more integrated solutions. The vision of the systems. So our framework solves these issues through 4 integrated components. That is, first one is we combine anomaly detection and bias monitoring into one unified systems. This allows earlier detections, better coordination, fewer blind spots. The next one is that is AI-driven digital twin core. We use adaptive machine learning models combined with fairness our training, physics-based systems knowledge. The third one is real-time HPC. The industrial system generate large amount of data quickly. So our framework supports fast processing, distributed computation, and real-time responses also. So explainable AI is very important in nowadays, though every decision is traceable and we have to explainable all the parts. So we provide feature important analysis, root cause explanations, fairness reports. Transparency is built into the systems. So this is our system architecture overview. So it covers, it is a 5-layer architecture. That is data acquisition layer, So here we mainly collect all the data from different sensors, devices, and whatever it may be. And mainly enterprises systems we are collecting along with the timestamps and tracking purpose also. The next one is data processing layer. It is here that is like a normalization, cleaning, and preparing the data as a complete solution. The next one is modeling our layer. So combines physics-based and machine learning models here. So integrated detection layers here is that is monitoring anomaly and bias together. So final layer is the feedback layer. So here adjust models and thresholds automatically based on the domains or our purpose. So this creates a closed loop system that continuously learns and improves. So here, this is our methodology. So first one is end-to-end detection. So from the starting point to the end, what all are the methodology we are using here, I am mentioning here. So in the left side, anomaly detections, bias detections, and fairness, and a digital twin core environment. The three pillars is here. So digital twin core environment is mainly that is replica, the virtual replica part of things. All the works is done in this part. And apart from this continuous synchronization between the physical stream and the digital model, everything is handled by this digital twin core environment. And accurate system state modeling for prediction and simulation also, it is coming under this digital twin core environment. The next one is bias detection and fairness layer. This is here that is continuously evaluates fairness metric. So activating mitigations mechanism when bias is detected. So monitoring compliance with the governance and regulatory standards also we are following under this bias detection and fairness point. The third one is anomaly detection layer. So here identify abnormal systems, abnormal behavior through behavior analytics, statistics, and machine learning based detections methods. Another one is modular component that can be extended based on application needs. The key message is integration of anomaly detection and bias monitoring work together within the digital twin core, not as a separate organ. The unifying design ensures performance, fairness, security, and reliability are monitored simultaneously, creating a trustworthy AI-driven digital twin systems. Sorry. The next one is anomaly detection technique. So we use a hybrid approach here, that is statistical monitoring for quick detection, machine learning models for complex patterns, and time series models for temporal behavior. This improves accuracy and reduces false alarms. These techniques, that is bias detection and mitigation techniques, biases is addressed at three different stages, even the data level, model level, and evaluation level also we are mitigating this bias. That is in data level, that is we are addressing rebalancing and reweighing. And model level, that is fairness our training we used to continuously whenever it is required we are doing. And evaluation level monitoring fairness metrics. This ensures fairness is measurable and manageable. This is our integrated framework for joint detection. So here these pictures, it shows the physical systems, and the next one is core functionality. Core functionality, it is nothing but digital twin core as a virtual replica, and along with the anomaly detection engine with the bias detection engine also. Once everything is we are addressing, then it will tends to that is models refinement and decisions optimizations for performance and trustworthiness. So the systems operates continuously, data is collected and anomalies and bias are detected, results are analyzed together, that model adjusts automatically when it is required, performance is validated. This loop maintains reliability and fairness over time. So here our experimental validations, we are using this framework into our vehicle tracking case studies. We are supply chain management, we are working here. So here we tested our framework using real-time vehicle tracking scenarios with the GPS, IMU, and camera data. We introduces realistic problems such as sensor failures, GPS spike, and geographic bias between regions also. Compared to separate detection systems, our approach achieved some of the main points like higher anomaly detection accuracy, earlier detections of drift, fewer false positiveness, and improved fairness across regions. This confirms the benefit of joint monitoring. So finally, that is conclusion. To conclude, our digital twin system faces an operational safety gap caused by fragmented decisions, bias accumulation, and limited transparency. Our framework addresses this gap through integrated anomaly and bias detection, real-time adaptive learning, embedded ethical safeguards, full explainability. The result is more reliable, fair, and trustworthy digital twin systems. That's all. Thank you. Thank you for your time, and I look forward to your questions.
So, ma'am, one question is that your twin system that you have integrated in your model, if we can, if we can replace it with some other technology, so what is the benefit for this twin technology you have integrated in your model?
Yes, ma'am. Actually, in general, that is twin means that is virtual replica. We are just collecting the data from the real-time scenario and we will make a model. And before taking any decisions, we just check with our models whether this is the performance is okay, or then we will provide to the real-time scenario. But in this case, that is we are that is getting the data itself, we are finding out whether this data, whether anomaly is there, bias is there, any that, because is the real time scenario, right? So any other that is ingestions kind of things, that is data is injected in any other format or any other anomaly, then we will that is feedback to our real scenario. So we are working in the two separate way. This is how here we are presenting the anomaly and bias in the digital twins, how the process is going on, what all are the steps we are taking in the real time scenario. But a replica, in the sense we are working there, but that is separate point of view. So here mainly focus on anomaly and bias detection, because we are getting heterogeneous, different kind of large volumes of data. Sometimes we couldn't understand whether the sensor is failure or not, or whether we are getting the correct data or not, or otherwise any human fault or inject any kind of data is
Okay,
injected
so
or
it
not.
is
So
basically a validation of the data, what kind of data you are
yeah,
putting for.
yeah,
Okay.
systematically we have we used some both the things, that is clusterings and classifications also. We are finding out what all are the anomaly, how the accuracy is there, that is whether really that data is the spike data or the normal behavior data. So those pattern also we are analyzing and we are giving the real-time scenario.
Okay, ma'am. Thank you so much. Nice presentation.
Thank you, ma'am.
I would like to ask another session, yes, ma'am, if you have any question regarding a previous presentation. Okay, Vidhi,
Yes,
please go ahead for next presentation.
yes. We now invite Themba Masumbuka to present his paper titled An ICT-based framework for enhancing team productivity in agile software development, a South African study.
Good morning, everyone.
Good morning.
Yes, I hope you can see my presentation.
We can see your screen.
Okay, I just want to put it in presentation mode. Okay, thank you, everyone. My name is Themba Masumbuka. The study was done in South Africa from the University of South Africa. So, software development productivity has been debated for decades, but it's conceptually unsettled, particularly when looking at agile environments. While agile methods have reshaped how we build software globally, how we understand and measure productivity within these teams has not evolved at the same pace. How much of the dominant theory still reflects plan-driven thinking? Much emphasis is put on the output-based measures, and it does not look into the collaborative and adaptive nature of agile work. In the study, we explore how agile practices influence team productivity within South African software organization and propose a contextualized ICT-based framework to enhance that productivity. The aim of this research was to investigate how agile practices influence team productivity in South African software development organizations and to synthesize the insight into practices and a contextual sensitive framework. Three focus areas that guided these studies. First was how agile practices are interpreted and adapted within specific organizations settings. The secondly, which human, organizational, and technical factors are most significant in shaping team productivity. And lastly, how can these insights be integrated into a coherent and actionable framework? Rather than treating productivity as a fixed ratio between inputs and outputs, we approach this as something that would shape that is shaped by the complex context, relationships, and life experiences. Historically, software productivity has been measured through indicators such as line of codes, function points, codes estimation like COCOMO. These approaches were developed within a plan-driven environment and tend to privilege output volume over coordination effort, learning, adaptability, and quality. In agile settings, productivity increasingly reflects team-level capability, including delivery flow, sustainability, shared understanding, and responsiveness. Yet, despite the widespread of agile adoption, empirical research in agile productivity, particularly in emerging economies, remain limited. South African organizations operate within a distinct socio-economic conditions, constrained resources, global competitive pressure, a diverse team composition, and varied level of agile maturity. These contexts, uh, these contextual realities influence how agile is interpreted and performed. Therefore, we needed to do this research to reflect these realities. We conducted an exploratory, quantitative, multi-case studies involving two companies in South Africa, which have more than 4 years of agile adoption. One company operated in a horizontal collaborative structure, and the other adopted scrums with selected practices of XP and exhibited a vertical management structure. Data were collected through 8 semi-structured interviews and 2 focus groups involving developers, product owners, team leaders, and software engineers, and senior managers. The study was grounded in an interpretivist paradigm where productivity was not looked as an objective metric, but a socially constructed experience shaped through interactions. Using qualitative content analysis, we applied open coding, thematic clustering, abstraction into higher order structures, and thematic saturation was monitored to ensure adequacy and rigor. So to ensure that the trustworthiness of the study, we use triangulation across roles, the companies, members checking and maintaining a clear audit trail. Ethical clearance and confidentiality were strictly observed. These steps strengthen the credibility and analytical rigor of the findings. So in our findings, the first major findings indicated that people drive productivity. Participants consistently emphasize morale, commitment, collective ownership as a central to performance. Strong teamwork, cohesions, and enable faster coordination and smoother resolution of blockers. Importantly, while processes and ICT tools are necessary, they cannot compensate for low morale or poor collaboration. This reinforces that productivity in agile teams is fundamentally human before it is technical. Second key findings were identifying of 5 related themes influencing productivity. Those are the team design, training, turnover, teamwork environment, and task construction. Balanced team composition and skill diversity supported collaboration. Continuous training enabled consistent practice. Turnover disrupted collective knowledge while stable teams improve flow. Supportive environments and clearly constructed tasks enhance coordination and risk handling. Together, these teams demonstrated that productivity emerges from interactions factors rather than isolated practices. First, productivity is evaluated at the team level, not at the individual level. This aligns with the Agile's emphasis on collective goals. Secondly, productivity reflects a team's ability to convert time, skills, and work in progress into valuable increments, evidenced through throughput, cycle time, shared perceptions, and progress. Thirdly, productivity is socio-technical in nature. It emerges from the interactions between people, processes, tools, and organizational conditions. So in our framework, it's based on these insights, we develop an ICT input processes and outcome ICT-based framework. Team design, skills, environment, and task construction. Task structure functions as input. These influence the team's processes, such as communication, coordination, which in turn shapes outcomes, including quality, timelines, and customer satisfaction. Practically, organization should prioritize team stability and training, invest in short feedback loop, and adopt a composite productivity measures. So in conclusion, productivity emerges from social technical interactions over time, not from single practice or metrics. Thank you.
Thank you so much, presenter,
Thank
for
you.
presentation. I would like to ask our chair, ma'am, any question regarding the presentation?
Yes, thank you. Thank you for your presentation. From your findings, is there one simple change that has noticeable effects on team productivity?
You can please repeat that. You said there's a one what? Can you repeat that for me? I didn't get the question clearly.
Okay. From your findings, is there one simple change that had a noticeable effect on team productivity?
Yes, actually, communication. When communication is put at it's open at any level where members can directly communicate to upper level managers, it ensures that everyone feels noticed in the team. It boosts their morals and that the productivity then it's enhanced in that way.
Great. Thank you. Nice presentation.
Thank you.
Yes, ma'am. We now invite Kevin Lajpop to present his paper titled Barrel Shifter Optimization of O2 MD2 on ARM Cortex M4 Efficient Key Generation and Encryption.
Good morning. Can you see my presentation?
Yes, we
Yes.
can see you. Good
Okay.
morning.
Hi, everyone. My name is Kevin Lajpop. I am from Guatemala, and I am PhD student at the computer science at the Universidad Francisco Marroquín. Today, my presentation, I will present my work titled Barrel Shifter of Optimization of the O2 MT2 on the ARM Cortex M4 Efficient Key Generation Encryption. And this work, I study how small architecture transformations can improve embedded cryptographic performance without modify the underlying algorithm. So um, the microcontrollers are increasingly required to execute public key cryptography. However, they operate under strict constraints, limited energy, like latency, budget, restricted memory, and many optimization effort focuses change the algorithm. And instead, I asked how far can performance I improve if I only align the implementation with the hardware. I don't modify the cryptographic design. I only restrict the implementation. This is very important of my study. And my target platform for this investigation is ARM Cortex M4, and the Cortex M4 is excuse me, 32 in order processor with the DSP extensions, and importantly, is a fuse barrel shifter. The barrel shifter allows shift and rotate operation. We combine it with arithmetic instructions. It's a single cycle. This feature is the center of the my optimization. I not use or reduce use our arithmetic operations, for example, multiplication and divisions, and use the barrel shifter or shift and rotate operations. The cryptographic context, the algorithm of O2MT2 is a ring-based structure, for example, n-true. N-true primitive operation over the ring and R sub Q. In my experiments, I use n equals 16. A schoolbook convolution is used, and I focus on the only key generation and encryption. I deliberately avoid modify the algorithm structure. All improvements are instruction level transformation. I don't modify the mathematic algorithm. I am only focus on the extraction and the transformation and use the barrel shifter. And the baseline implementation is a fully portable C code. It uses the model operation for the index, wrap around it, use the compiler generation, generate division for the power of 2, perform a modular reduction inside inner lobes. This baseline serves as the my correctness performance reference. The strategy is I apply three main optimizations or transformation. Replace module n with the bit masking. Replace the division by the division by power of 2 with the shift bias redundant, and the move modular reduction outside of the hood loops or lazy reduction. Importantly, all outputs remain bit for bit identical for the baseline. This is a very, very important. And I verify a strict equivalence across all the altered cases because the algorithm is not modified. So the first or optimizations is eliminating model replace. Replace signs the n equals 16 is a power of 2. I replace j equals j plus 1 module n with the j equals j plus 1 and j and n minus 1. This remove the divisions operation for the convolution curve. The result is branch-free, predictable index stepping. The second optimization is replacing division with the shift. Division by the 2 power key is expensive of the Cortex M4 because the Cortex M4 is a small CPU with a small memory or another resources. The user barrel shifter, I implemented redundant shift, use X plus VIs, shift K. This achieves correct symmetric redundant as single cycle. This is a very important in my optimization because I use or the Cortex M4 use only a single cycle operation. And the lazy reduction is a baseline reduction happens inside in the inner loops. I extrude the convolutions, accumulating and in a bits reduce after exit of the hood loop. These reduced instructions come inside of the critical path. And the experimental setup use or implement and these three optimizations is I evaluate on the STM 32 with Cortex M4, and my methodology, I use 100 repetition per kernel, one iteration discarded, same compiled binary, T double T cycle counter, and the 95% confidence intervals. I isolate the kernel cost and only focus in the time or the cycles of the core or the CPU, and for example, metrics, for example, metrics with temporality or another metrics are discarded. Only focus in the time with the CPU cycles. And the results, the key generations, I have 3.766% speed up, and the encryption 44.32 speed up. The confidence intervals is not overly variance remain low in both versions. And the encryption shows slightly higher improvement because it exposes more computations operations, contains more index wrap around, and provides more opportunities of the shift replacement. Why 4% matters? Because the problem may appear modest. However, I did not change the algorithm. I did not change data format. I did not increase memory usage. I did not modify security properties. This is structural improvement, no heuristic turning. On the fixed frequency MCUs, cycles reductions directly translates into proportional energy saving. And for final, my presentation and limitations, this study only evaluates n equals 16, focusing on the only key generation and encryption, targets Cortex M4. I exclude decryption to its sensitivity to redunding and the ring alignment. I plan to address in the future work on another, for example, platform, Cortex A72 on a Cortex A76, because but in this investigation only center and the Cortex M4 because is a platform more small or more with more the small the RAM on and other limitations. And the conclusions, I demonstrate that small discipline architecture aware transformations yield reliable performance gains in embedded cryptography without changing the algorithms. I achieved 3.76 reduction for key generation, 4.32 reduction for encryption. This improvement is reproducible, bit exact, and the hardware aligned in another optimization. And this is important because I demonstrate that and when I have a hardware or limitation hardware, this is not limited because I optimize an algorithm, and this is scalable because I will use another hardware more with more resources, for example. I will, and this is a final my presentation. Thank you very much, and I will happy to take your questions.
Thank you. Very interesting work. Could you explain how these optimizations might influence the performance or efficiency of embedded system in real-world applications?
In future application, or I don't understand your question.
I mean to a performance of embedded systems in real-world applications.
This optimization or this algorithm used with in the another areas or yes, areas. For example, IoT, because they use and communication with wireless or with another communications. For example, say wireless is the more in the first application because this connectivity and another scenarios and even this is important because in the future the quantum computation is a very risk for our digital environment and the all our communication is a and the risk and the use this API of the algorithms with the more efficient is very important. And the use this, for example, this optimization is a very more speed, very more efficient with the resource. And this is important because it is another this is another solution and for example, the risk quantum computation and another risk and the attacks.
Thank you.
We will now move on to the next presentation. We now invite Orevotse Boikanyo to present his paper titled From Acceptance to Adoption, a TAM-informed framework for business chatbots in South Africa.
Good morning. Can you see my screen?
Yes.
Yes, we see.
We can see this.
All right. Morning. Yes, so I'm Orabutse Boikanyo. Today I'll be presenting my research from acceptance to adoption, a TAM informed framework for business chatbots in South Africa. This was done in South Africa through the University of Pretoria. So under background and related works, we have chatbots are widely adopted across industries to deliver 24/7 cost-efficient customer service and faster response times. So these were the main factors where chatbots exceeded human agents or what people preferred when it came to chatbots. But under prior research, it shows that while it improves efficiency, they still struggle with complex inquiries, intent interpretation, and emotional sensitive interactions. So to give an example with this, if someone asks a chatbot two intents, for example, if they want to check the size or how far their order is, usually they'll get confused or they'll get it completely wrong. Also, if a user then gets irritated or angry, usually chatbots aren't able to manage the situation. So it also causes more stress and anxiety and churn from chatbot usage. And then under existing studies, most of the research around chatbot adoption is mostly global. There is limited research in Africa and South Africa. And usually the industries that have this research are healthcare or fintech. So there isn't a cross-industry pool of research when it comes to chatbot adoption. So that was the research gap that we also identified. So what's the problem? So in South Africa, businesses are rapidly adopting chatbots, yet customer satisfaction remains moderate despite high usability. We have seen an increase in chatbots being deployed for customer service across South Africa, but the service that people are getting is still moderate. So the satisfaction is not going up as companies or as the different industries thought it would. Chatbots perform poorly with complex issues, leading to customer frustration and low trust. So as explained before, with the misunderstanding and the complex issues not being able to be handled by the chatbot, it just creates low trust or limited use. So also ease of use does not translate into preference, as most customers still favor human agents for meaningful interactions. So although the chatbots are easy to use, you can access them over WhatsApp, or over the net, mostly WhatsApp though in South Africa. There's still that friction, even though they are easy to use or easy to access. So the core problem we identified is that there's no practical framework to guide organizations in aligning chatbot capabilities with customer expectations. So our framework that I'll get into later is going to try and address this identified issue. And then under theoretical framework, we used the term acceptance model. So this is widely used to predict user acceptance of new technologies. That's the main reason we chose TEM. Chatbots are still a new technology, well, in Africa and South Africa, that is. And then prior research also highlights that there's a limited number of, prior chatbot studies have been limited in number and scope in Africa, with most focus on healthcare and fintech and few applying TEM. So as mentioned before, there is a scarcity on that one. So we mainly focused on the following constructs in the TEM model. So perceived usefulness, perceived ease of use, attitude towards use, behavior intention, and actual system use. So under our methodology, we utilize the we utilized a quantitative cross-sectional design. So we measured data from a population at a single point in time. That was June last year. June 2025. So what we did is, so it's even in the second point, we only targeted participants who have interacted with a chatbot 12 months prior to answering the survey. So that was the time span given. And then our target population was South Africans over the age of 18, as mentioned before, who have interacted with a chatbot 12 months prior. So we analyzed and cleaned the data. So we worked with 171 responses. The total respondents were 207. So we had to omit about 36 respondents. And then under reliability and data analysis, so we used a prospective analysis where we calculated what the minimum sample size is. And the answer we got was 34. So yeah, that covers the 171 covers that prospective analysis or the power effect. So that was conducted. And then we used descriptive statistics to identify the different patterns and the adoption gaps. Okay, so under results, usability and complexity. So this looks at perceived ease of use and perceived usefulness. We'll start with perceived ease of use. So 80% of users found chatbots user-friendly with a good UI, and 81% valued their 24/7 accessibility. However, the problem that was identified is 46% were dissatisfied with response times and limited options. So the options that were there didn't always cater to what they wanted to get assistance on. And then under the perceived usefulness, excuse me, when we measured the perceived usefulness, usefulness declined with the complexity of the tasks. So the more complex the task was, the more usefulness or the more satisfied the user was. So that was the dip that we saw there. And then under attitude towards use, while 47% of users had a positive experience, under the issue, you can see that 21% had an actively negative experience, and a large number of 32 remained neutral. So this could be that the chatbot wasn't that impressive, or like again, maybe it didn't cater fully to what they were trying to get assistance on. And then under behavioral intent and actual use, 56% of people would recommend chatbots. But when we ask them if they had to decide between a chatbot and a chatbot and a live agent, only 28% opted for chatbots. So we can see that chatbots are still the second option. They're not really the first option, or they're not integrated, or they're not at the level where we think they are. This is in an African or South African context, that is right. So the major takeaway is while chatbots are validated for simple tasks, the majority of customers still prefer human agent for complex tasks. Positioning chatbots as a support tool rather than a replacement, which is a problem we're seeing where companies are trying to minimize their staff or assign most of the work to chatbots in kind of like replacing live agents. But as we can see, it's not what people want. So to solve this problem, we are positioning the 8-stage chatbot implementation framework, basically a framework for companies or businesses to follow when they want to implement a chatbot. So the first stage is alignment. This is where you'd capture top queries from call logs to identify automatable tasks. So basically automating the easier tasks or the most frequently asked tasks that a chatbot will be able to handle. Stage 2, capability assessment. This is where you'd assess your systems and see if there are any API integrations that can happen. Another major important point is the company or the business needs to decide if they want to do it on-prem or in the cloud. This is just to cater for data privacy and any policies or regulations. And then under stage 3, we have user interface design. So we prioritize mobile-friendly interfaces. We believe most customers or most people would engage with these chatbots via the mobile devices through like Facebook Messenger or WhatsApp. And then number 4 is integrations. So securely integrating with CRM, billing, and order tracking using standard APIs. So this will go with the use cases, right, that the company has identified or the problems that they're trying to solve. This is when they'll plan the integration and how that's going to work. And then stage 5 is the handover model. So establishing triggers of when the chatbot should hand over to the agent. You'd use things like sentiment analysis. So if the customer or the user is repeating their query, or if they're repeating their question, or if the language is getting a bit heated, then that will then be a trigger to hand over to an agent for assistance. And then under deployment, you'll launch slowly with a sample group to monitor performance and minimizing reputational risks. So another plan is to probably identify the group that you'd like to test with. We'd suggest the younger generation. From the research, we've also seen that the younger ones, well, yeah, I'm included in that. The young ones prefer chatbots over live human agents. So testing and seeing if it's actually satisfying their needs. Are they coming back? There's no high dropout rates and stuff like that before you roll it out completely. So that'll also help you gather information and fix the model if you need to. And then transparency, clearly publish capabilities and limitations upfront and provide visible path to reach a human agent. So some chatbots have what we call anthropomorphism, yes. So they behave like humans and they speak like humans. So sometimes it would confuse the user and adds to frustrations because they'll think that they're actually talking to a human. Meanwhile, it's a bot. So being clear about that and the capabilities will reduce that. And then stage 8 would be improvement, basically tracking the matrix, seeing which use cases are utilized the most, what you can add, what you can remove, and having CTA scores where people then can rate the experiences, and then you can fine tune the chatbot from there. Okay, so under strategic recommendations for businesses, so at the moment, we suggest positioning chatbots as a first-line support, not total replacements, mandatory escalations, clear escalations to live agents for complex queries, so sentiment analysis and those triggers, and then upfront transparency, stating the chatbot's capabilities and limitations from the get-go. And then in conclusion, under our contributions, so the 8-stage framework serves as a roadmap for executives, architects to balance the automation cost with service quality, contextualizing TAM, fine-tunes the TAM acceptance models for developing countries, and addressing barriers, specifically addressing African challenges by advocating for multilingual support and phased deployment. And yeah, that's me. Thank you.
We now ask the session chair to ask questions.
So, hi, very nice presentation.
Thank you.
Yeah. So according to you, what are the risk implications if you are using the chatbot in the business model at South Africa?
So I did mention the reputational risks where you have chatbots that are not catering mainly to the major problems or why people are reaching out. So if, for example, I have an issue with my product and every time I ask the chatbot how far my refund is, and it will always give me the same message or there's no handover, I'd be irate or very irritated, and I'd go to social media and complain about the company's reputation, how they're not taking care of their customers, how their chatbot is completely useless. Yeah, so those are some of the risks that we've identified.
Any kind of data privacy regulations you have implemented in your chatbot?
Yeah, so that's I think it was the second or third point where you then decide if you want it to be hosted on-prem, so no information leaves at all. So I know for government, banking, and fintech, they always opt for on-prem. They don't want any of the data leaving. Also in the integrations, you'd make sure that your APIs are using OAuth 2 or higher. It's not easy for people to hack or can't find the word I'm looking for. But yes, basically making sure that the integration is secure between your systems as well. Yeah.
Okay, good. Thank you.
Thank you.
Michelle, ma'am, do you have any questions?
No, thank you. Nice presentation.
Thank you.
Thank you, ma'am. We will now move to the next presentation.
Can you hear me?
Yes. Excuse me, sir. I'm really sorry to interrupt. Just an introduction of you first. We now invite Laurent Barthélemy to present his paper titled Maintenance Vessel Berthing to a Wind Turbine in Irregular Sea State.
Can you see my screen? Can you see my screen?
Yes, we can see your screen, but it is blanked out.
Okay, so tell me if there is any issue. So I'm about to talk about maintenance vessel berthing to the wind turbine in an irregular sea state. Last year, I did a presentation with ICICT with quite a similar topic, but I get more into the details of what is a real sea state, which is an irregular sea state. To present the issue, so here is a photograph. It's a top view, plane view of a maintenance boat docking against the boat landing of a wind turbine, which is the yellow structure on the left side. In order for a technician to go and jump on climb the ladder, the boat needs to overcome the sea state.
Sorry to interrupt, dear presenter. Your presentation is not visible.
Okay, so I will start again. Can you see me?
Yeah, we can see you, but your presentation slides are not visible.
Okay, so let me share it again. Can you see it?
Yes, now it's visible.
Okay, good. Sorry for that. So I was at slide number 2. So berthing a maintenance vessel against a monopile of a wind turbine. So in order for the maintenance vessel to make possible for the technician to climb the ladder, you need to overcome the sea states. The sea states affect the boat with the surge, which is the horizontal motion of the boat from the left to the right when it is submitted from a wave coming from the left to the right as well. In order to model such an issue, we have to account for the deformable fender, which is a how do you say? Which is a foldable object between the ladder on the boat. In order to model such a system, we need to model on the left side the boat landing fender interface, which is a point MC. On the right side, we need to model the boarding point, the boat boarding point fender interface, which is the point A minus. If you look from an elevation this time, the technician, in order to be able to jump from the boat to the ladder, needs to watch for the boat heave, which is a boat vertical motion at the front of the boat. You see the motion ZA minus. On the other side, he needs to watch for the fender friction against the ladder, which is in order for the fender not to slip, to glide. So he needs to watch for point ZMC not to move so that he can work on the ladder. On the other hand, regulation recommend that 95% of the wave should pass with no fender slip above one ladder rung. So how to model this? So it is where there is a change compared to last year. Last year we did not account for the ship path history. The fact is that a ship does not move only depending on the wave which comes straight on the boat, but the boat is also sensitive to its past motions. We call it the memory effect due to the presence of the water surface. I have added in red this memory effect due to the boat history, due to the presence of the water surface. So for people who are used to sea-keeping equation, you have an equation which is quite similar to mechanical equation actually. Inertia times acceleration plus damping times velocities plus stiffness times displacement, which is equal to the sum of the external forces applied to the boat. So where the equation gets more complicated is with the points, with the parameters in red, Ij, which is actually the added inertia of the boat due to the water, which includes from some retardation functions, which is also called convolution products. And if you look at the term Rij, which is the convolution product, it also occurs in the damping terms, which are the dampings times the velocities. If you look at the model of the boat motion equations, once you have reorganized the equations, you get a typical mechanical equation. So matrix of inertia times acceleration plus matrix of dampings times velocity plus matrix of stiffness times motions equal forces. The abbreviation for AGA is the sum of the inertia of the boat and the added inertia due to the water. If you get into the details, omega t is the wave instant pulsation, which is the wave which comes at the instant t to the boat. Nconv actually includes from the ship motion. It actually tells you how far back in the past you need to go in order to account for the boat motion history. It's a trial method, test on trial. F, if you get into details, is the sum of various forces which are famous for aerodynamic emissions, which is the incident wave force, the diffraction wave force, and you have also the force due to the propeller, to the boat propeller, etc. And you have also some memory forces which account actually for the boat's past history. So these forces actually are included here. So these are here the incident on diffraction forces, which is nothing special. It is common in aerodynamics. You also have these memory forces actually, which looks like this. So actually you account for the past times in the history of the boat, right before the instant t. These are damping terms. You have a matrix of damping coefficients times a matrix of the past ship velocities. So as regards the fender, you have to account the fender as a single point, which is an approximation. So to keep it short, it is a simple equation where the fender fictitious point is submitted to a friction force and to a set of spring and damping forces. I will talk more into details if required at the end. To get straight into the results. So you can see the wave action of the boat on the boat. So ZMC is the vertical motion of the fender. You see it for a swell of 2 meter HS, so significant wave height, on the period, a wave period of 7.4 seconds. You can see that 86% of the waves pass without slippage. So if you look at the curve in red, you can see a succession of plateaux, which is when the fender does not slip, where the man can go on the ladder, but it is cut between with various transition periods, which make it that less than 95% of the waves pass without slippage. In red is the boat front motion, and in blue is a horizontal line showing the height of a ladder in the boat landing, of a ladder rank, sorry. So the next curve is for a smaller wave height. If you look carefully, you can see that there is less transition phases, and actually you meet 95% of the wave passing without slippage. In other words, you almost meet the guidelines. This is a table showing the results. So actually, it shows that the modeling shows its limitation. On the left, you have the table with a 2 meter HS. On the right, this is with 1 meter, 1.5 meter significant wave height. So, and you show for various wave periods from 14 to 4 seconds how the slippage is affected. So for 2 meters, the good news is that you have less than 95% of the wave passing with no slippage apart from a problematic point, which is for long wave periods of 14 seconds. On the other hand, for 1.5 meter seconds, you almost reach the 95% wave without slippage, but amazingly, for smaller wave periods, it does not materialize. So, in other words, with 1.5 meter HS, you get this recommendation, this guideline met, but for only waves between 7 and 14 seconds. Another issue is that for small wave periods, you should be able to board, but the model does not meet it. So, in other words, it means that we will have to challenge the modeling of the fender using these linear springs. As a conclusion, modeling using linear springs on dampers shows its limitation. Actually, it's even more significant in such seas as Mediterranean seas, where you have wave periods, which are smaller. Fender stress strain law, which is nonlinear, and then this is the next topics you will have to discuss about. And to finish, this is the set of the horizontal and vertical springs on dampers on vertical forces, vertical friction forces acting at the front of the boat to modulate the interface with the boat line. Thank you for listening.
I ask the session chair to ask questions.
Thank you for the presentation. I want to ask which factor had the biggest influence on your boarding results?
Okay. Boarding is mainly sensitive to the vertical wave force against the keel of the ship. This is the main destabilization force to the boat.
Thank you. Very clear and insightful.
Thank you.
Ruchi ma'am, do you have any questions for the presenter? We will now move to the next presenter.
Thank you.
We now invite P. Periyasamy to present his paper titled The Use of Organoid Intelligence in the Indian Education Industry.
Good morning, everyone. Yeah, I'm Dr. Periyasamy here from India. Here it is good evening. Up there, those who are listening to me from India, for you all it is good evening. For those who are listening me from UK, it's good morning. Anyway, okay, let me share my slides with you guys. Is my slide visible to all of you? Hello?
Not now.
Okay. Let me share it again. Give me a minute. Yeah. Is my slide visible to everyone? Hello?
No, we cannot see the slides.
No, you are not able to see. You are sharing
No,
screen, it says.
it's good now.
Yeah, now it is visible, no?
Now it is. It has come.
Yes.
Yeah. Thank you. So I myself, Dr. Pereswamy, and along with me, Mr. Ravi Mohan, and one more faculty member, Dr. Delecta Jennifer, and Sangeeta Badmanabhan, and Divya Ranjani ma'am, Devi Sangamitra ma'am. So we 6 of us joined together and prepared this paper, and I am here to present on behalf of them as well. So we are representing the Savita Engineering College, Tamil Nadu, India, and our slide presentation is going to be something like this. So first slide will be talking about the introduction, and next we will be moving on to the objectives, then the literature part, then slowly we move on to the methodology part, then application, then methodological framework, then key barriers, case study, then ethical and regulatory challenges, then infrastructural facilities and funding challenges, then recommendations, finally the conclusion part. So this is how we have arranged the slides for you. So let's move on to the introduction slide now. So with all your kind cooperation, I am in the introduction part now. So organoid intelligence combines the neuroscience, bioengineering, and AI. Represents next generation biocomputing beyond the silicon-based artificial intelligence. Strong relevance for Indian higher education and research ecosystem as well. And this makes it a potentially transformative technology for education and research. And to move ahead, we are going to discuss about the objectives of our study. Our objectives are 4 actually. The first one is about analyzing the impact of organoid intelligence on Indian education and identify infrastructural, ethical, and policy challenges. Then exploring the interdisciplinary curriculum innovation. Finally, providing the policy and implementation recommendations. Then to move ahead, we have the literature background. We have got more than 100 studies which are already being done on this organoid intelligence over education industry, and we have gone through that. And from that, some significant studies are being listed out here. The first one talks about brain organoids demonstrate learning and adaptability, this brain. And organoid intelligence offers high energy efficiency and cognitive flexibility. Then our own national educational policy 2020, India has got this NEP 2020, encourages interdisciplinary technologies in education as well, where we have talked about the organoid intelligence role in education as well. Then to move ahead with regard to the methodology, qualitative meta-analysis of global and Indian studies, review of policy documents and institutional reports, use of conceptual frameworks and comparative analysis. Then with regard to the adoption of OI in education, neuro, artificial intelligence and biocomputing education, then cognitive modeling and simulation labs, advanced research training in neuroscience and artificial intelligence as well. And we have a methodological framework which talks about the institutional readiness and funding, bioengineering lab setup, then organoid culture and modeling. Finally, it talks about the ethical governance and monitoring as well. Then some key barriers are there, and those barriers are relating to ethical concerns, sentience and consent, and then infrastructural limitations. Then we have high financial requirements, and finally the policy and regulatory gaps as well. And we have got the case study about this brain, demonstrated learning in neural organoids, validated feasibility of biological computation, then raised to ethical and safety consideration as well. Then with regard to the ethical and regulatory challenges, need for national ethical frameworks, governance of donor rights and neuronal data, then responsible innovation and innovation in education as well. Finally, with regard to the infrastructure and funding, requirement of advanced wet labs and MEA systems, limited access across Indian institutions, potential through public and private partnerships. And we have some recommendations as well. And with regard to the, we need to establish organoid intelligence centers of excellence. Then we have to develop interdisciplinary curriculum, Then we need to strengthen ethics committees as well. Then finally, we need to promote international collaboration. And to conclude, this study, organoid intelligence can transform Indian education and research in due course. Then ethics and infrastructure are the key enablers. A strategic adoption can position India as the global leader as well with regard to the organoid intelligence. Thank you for the wonderful listening and patience. Thank you very much. If there is any question out there, I'm here to help you out to answer.
Yeah, hello, sir.
Hello.
So, how much it is feasible to implement this organized structure in the recent NEP education policies
Yes,
in
ma'am.
India?
India. Yeah. You know that, yeah, NEP has got its own barriers, and this is again yet another barrier that we have. India is planning because India is having a huge population, a lot of barriers are there, and positively let us look into these things are going to be implemented in the near future as well. Thank you very much, ma'am.
Interesting topic. Thank you. And good evening.
Thank you, ma'am. Good evening.
We will now move on to the closing remarks. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part for this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICICT 2026. As a token of appreciation, we have I also thank our session chair for chairing this session. A token of appreciation to the chair on behalf of Team ICICT 2026 and Global Knowledge Research Foundation and partners. This token is for Professor Michal Oren, and this is for Professor Ruchi Sharma.
Thank you so
I
much.
kindly request you all to switch on the camera for a quick snapshot of the virtual conference.
One small request, ma'am.
You've been saying something, sir?
Yeah, I would like to say that we 6 of us joined together and presented this paper. We would like to have the certificate individually. That is only obligation from our side to the conference group.
Yes, sir.
Thank you.
Thank you, sir. I hope you have a great day ahead and take care. Thank you.
Thank you.
Thank you.
Thank you all.